All right, so here's section 7.5. We are going to do just some examples today, a review. So the first thing is you need a piece of graph paper. We're going to be working on a coordinate plane. So for this first example, I want you to go ahead and draw a coordinate plane, and I want you to label it by 10. So 10, 20, 30, 40, 50. You'll go all the way up to 80 on your x-axis, and then on your y-axis, go up to 60, and then on your y-axis going down, you'll go to negative 30. So go ahead and do that, get that set up, pause the video if you need. Once you have that set up, go ahead and you're going to plot these 3 points, 3, 20, 60, 50, 80, negative 30. Now, once you plot these points, it should look something like this. It should look something like this. So basically, what this question is asking is this a right triangle? It's actually not given to me. I want to know, is this a right triangle? Clearly this is not, clearly this is not, but this, I don't know. Right now it looks like it could be, but I want to make sure. So how do I know that this is a right triangle? So your question is this a right triangle? Okay, so already, what do you think the issue is about this? Why is this such a hard problem? Well, let's go ahead and count up the sides to see what are the lengths of all my sides. Oh, shoot. Well, hopefully you noticed I can't. Right now, these lines, they are not perfectly on an x or y axis, so I can't just count the length of them. But yes, there is a way, and that is my distance formula. So go ahead and write your distance formula. Remember from yesterday, your notes, your distance formula is the square root of the difference between x2 minus x1, but squared, plus the difference of your y values, y2 minus y1 squared. So that is sort of your golden formula that you need to know and know how to use. So is this a right triangle? Well, what I'm going to need to do is let's go ahead and call this, we'll call this distance 1, we'll call this distance 2, and then we'll call this distance 3. Distance 3. Now, technically, if this is the right angle I'm solving for, then the opposite side, this is going to be my hypotenuse. That's always going to be my hypotenuse. Your longest length and the one that points opposite of your right triangle. So if you need a reminder, this is your hypotenuse, which you can also think of as C. So is this a right triangle? If it is a right triangle, then a squared plus b squared should equal c squared. And I should write that up there, sorry. Then a squared plus b squared should equal c squared. Or I can think about this as distance 1 squared plus distance 3 squared should equal distance 2 squared. Well, let's go ahead. The first step is I need to actually know and find out what are these distances. What are these distances? Well, thank goodness I have my formula right here. So I can find the distances between the two. So this right here is 30, 20. This point right here is 60, 50. And this last point right here is my 80, negative 30. So let's go ahead and find the distance for distance 1. What is the distance between this point and this point? Well, this distance is going to equal my distance formula. So distance 1 will equal the square root of, and let's go ahead and use this formula to start plugging in answers. Well, here are my 2 points. I have 30, 20, and I have 60, 50. So those are the 2 points that I want to know the distance between. And so let's go ahead. I know that this is x1, y1. This is x2, y2. So now let's go ahead and plug in what I know. So I have x2 minus x1, which is 60 minus 30. But I know that that's being squared. Plus, I look at my y's. y2 minus y1, 50 minus 20. Squared as well. All right, and now let's simplify. 60 minus 30 is 30, so that's 30 squared, plus 50 minus 20 is also 30, so I get another 30 squared. So I think 30 times 30, well, 3 times 3 is 9. Add my 2 zeros, this ends up being 900 plus 900. And 900 plus 900 is 1800. And I'm going to say that my distance 1 is going to equal the square root of 1800. And I could take out a calculator and say if I have 1800 and I square root it. Oh, you know what? I'm actually just going to leave this in square root form for now. Because this, if I find the square root of 1018, it gives me a long decimal. And so you know what? I'm actually, and again, this is okay. I'm just going to leave that side as the square root of 1800. So over here, I can write that my distance 1 is, this is the square root of 1800. All right, let's go ahead and try to find distance 2. So I would say go ahead and try to do this on your own. You can pause the video and then check your answer. I'm going to work out this problem on my own, and then you can sort of check in. So distance 2 is right here. So that's between these 2 points. So that's between 60, 50 and 80, negative 30. So I'll say that this is x1, y1, x2, y2. So then that gives me the square root of 80 minus 60 squared plus negative 30 minus 50 squared. 80 minus 60 is 20, so I get 20 squared plus a negative 30 minus 50, stay, change, becomes a negative 80 squared. 20 times 20, this is 400, plus, well, a negative 80 times a negative 80 is going to be a positive. 80 times 80 is equal to 6,400. And then 400 plus 6,400 ends up being 6,800. And all along, I want to keep bringing down. This is all going inside my square root. So I know that my distance 2 is equal to the square root of 6,800. So I can go back up to the top of my original triangle and say this distance 2 is really 6,800, but the square root of it. All right, I have one more distance to find, and that is distance 3. So distance 3, I'm going from here to here. So one point is, that's 30, 20, and the other point is 80, negative 30. So I could say this is x1, y1, x2, y2, and solve from here. So my distance will equal the square root of x2 minus x1, 80 minus 30, squared, plus negative 30 minus 20 squared. And let's simplify. 80 minus 30 is 50, so I get 50 squared. 50 times 50 is 2,500. Plus, well, negative 30 minus 20, stay, change. That's a negative 50 squared. And I believe, did I just solve that? No. A negative 50 squared, that's just going to be a positive, and 50 squared, 50 times 50 is the same, 2,500. So if I add both of these up together, well, 25 plus 25 is 50. Add my 2 zeros, and I get 5,000. So I can say that this is going to equal 5,000, but I have to remember that I have a square root here. So my distance 3 is going to be equal to the square root of 5,000. I forgot a 0. 5,000. So that's my last one. So I can go back up here and say my distance 3 between those 2 points is the square root of 5,000. And so now I can plug in and find out, is this a right triangle? I know it's a lot of work. So I'm going to use a separate sheet of paper to kind of show. So, is this a right triangle? Well, since I know that this is my hypotenuse, I know that d1 squared, so I could say d1 squared plus, this is d3 squared, is going to be equal to my distance 2. And again, this kind of represents if I have that a squared plus b squared equals c squared, I know that this is c. I know that this right here is going to be what it equals to. So now I plug in what I know. Well, d1 is equal to the square root of 1,800 plus d3 is the square root of 5,000. And this has to, well, we're seeing if this is going to be equal to the square root of 6,800. Now, the thing about this is, technically these are all still squared. These are technically all still squared. So this is really a squared plus that b squared, which will equal c squared. And what do you guys know about if something is being square rooted, but you are squaring it, what happens? Well, it just cancels each other out. So this is going to cancel each other out. This is going to cancel each other out. This is going to cancel itself out. So I'm left with 1,800 plus 5,000 should be equal to 6,800. And I think, is it? Well, 5,000, if I do 5,000 plus 1,800 plus, oh my goodness, well that equals 6,800. So my answer would be yes. Yes, this is a right triangle. All right, so that's just kind of an example. You work on finding your distances between points. If you have any questions, please let me know. And yeah, go ahead and you can work on some of your practice problems and we will go over the answers tomorrow. Take care.